Because staircase, wherever it is required, that is the staircase we will design. But wherever the ramp is required, we have to design the ramp also. Ramp also the same process to description to move from one floor to other floor. To move from one floor to another floor, or to get in and get out from space to space, from one space to other space. So that area we will utilize ramp. So with the help of ramp only, we have to move from one part to another part. And this is for utilizing the project based on the requirement of the ramp. So in the ramp also there will be types of ramp. Okay, in ramp also there will be a straight ramp, straight run. The name of the ramp is straight run. Straight run. Arc radius. Okay, so there are three types of ramp we can able to design. One is straight, another is arc. The curve we will call arc, and some of the area we are going to see this ramp is we are going to design with a round also. So that is arc radius. Okay, so here we can able to design this ramp in this way. Here also the ramp we are going to put some angle, and this will become like that. And here there is a floor, and this all considered as a slab thickness. So here the ridge slab thickness is minimum is 150, maximum 250. We can keep the thickness. Okay, the ramp thickness we are going to take. So this slab we will call a resting slab, rest slab, W-R-E-S-T, rest slab. So ramp slab we will call as a rest slab, and the staircase slab we will call as a ridge slab, ridge and rest. There are the two words, technical words, you just remember. For the ramp we are going to tell as a rest slab, W-R-E-S-T, rest slab. And for the staircase we will call as a ridge slab. These are the BIM technical words we are utilizing for making the design in the project, BIM model projects. So either the rest slab design we have to take minimum 150, maximum 250 is the thickness of the slab we are going to take here. Okay, and the slope. Here the slope is from 1 degree to 30 degree is the slope angle we are going to take for the ramp, slope angle. Okay, so here there is one formula is there. Slope is equal to length of ramp divided by 1000. This is the formula for slope angle. Okay, so here the slope angle is equal to length of ramp divided by 1000. So you have to decide the slope angle of the ramp, because here the slope angle is going to be taken from 1 degree to 30 degree angle it is going to be taken. So slope angle is based on the length of the ramp, means how much length your ramp is going to be designed. Based on the length you have to division with the 1000. If the length of the ramp is coming some 1500, if it is there, so 1500 divided by 1000, so how much it is going to become? Some 1.5, means that 1.5 is the starting values of ramp slope. So 1.5 is the 1.5 angle, 1.5 degree is the angle starting slope. Means the ramp is going to be start from 1.5 mm slope to top of the floor. So here with this formula only we will able to design the slope angle of ramp. Okay, clear? So this way we will be able to work out for the ramp. Now here in ramp also, the straight ramp, we are going to design the ramp here like that. Here also the ramp will become this way, straight ramp. Here it will become like that. So in the straight ramp also, this area we will call as the landing area in the ramp. Same as steps, but here there is no steps, and this is the runway. And here we will put as a up. Up means from here we are going up, and in between there is a landing, and after landing again up. Like that we are going to move the point. So here where there is the width is coming, this width we will call as a run width. Again the same as staircase, run width, and the run width is minimum is 1000 mm. Here also the ramp run width will be 1000 mm. We have to keep everywhere. Don't keep less than 1000. You can keep more also, but 1000 is the standard width of the ramp, the moving, the run width. And here the landing also will be there. So we can design the ramp like that also, or we can design the ramp this way also, because only one way. There is no landing, nothing will be there. And this type of ramp we will call straight ramp. There is no landing, and below it is going to be make it up. So whenever you are going to sketch the ramp, you always start from your end and you have to move topward. So it is going to be designed the ramp from one floor to the next floor. And here your ramp, or when you are going to design the straight ramp, we have to put the distance, because from here to here, what is the distance we are maintaining? If you are maintaining some 2000 mm, so here also you have to maintain the distance as 2000 mm. So now your ramp total length will be 4000 mm. So 4000 mm divided by 1000, you will be get 4 degree. So your ramp starting slope angle will be 4 degree. You have to start with 4 degree angle from bottom. And when it is going to touch the top of the floor, maybe the angle may be changed, but the starting angle will be 4 degrees. Like that, the slope angle you have to decide by measuring the length of the ramp everywhere in a project. This is the arc ramp. Arc ramp means the ramp will become like that, arc. It will become like that. Some of the basement floor, if you go, you will find this type of ramp will be there. And here, this is the run line. This is we will call the run line. And here we are going to put as up. From here to here it is moving. This is arc ramp and this is arc radius. If you are going to put some arc radius, so this type of ramp also will be there. It will be look as a round shape. So this type of ramp we are going to put. And here, from to here, what is the radius we are maintaining? So if you are maintaining some 500 radius, so 500 radius only, the ramp is going to be designed in this way. And here we are going to put as a up. So like that, we can able to maintain the radius, or with the help of arc. Arc means this is the start point. This is the start point, this is the mid point, and this is the end point. So start, end, mid. These 3 points we will call as the arc ramp. And here with the help of R we are giving radius value. So the R value when we are going to give, that is arc radius. And here also the run width of the ramp is 1000 mm only. Here also the run width of the ramp is 1000 mm only. So wherever you are going to design any ramp, the run width will be minimum 1000. But for the parking area, you can see there is a big space will be there. So minimum 1000 and maximum you can able to take 5000. So minimum 1000 to 5000 you can able to take the run width of the ramp. And every ramp you can see they are going to put some grooves. This you can see every ramp there will be some lining will be there, and that lining we will call as a groove. This groove will be make you not to slip. It will be take the torque. You know the properties of the torque. It is going to give the torque properties. It is going to give the torque. So that is the reason you can see every ramp they are going to put not finishing properly. They are going to put some rough finishing, because when the vehicles will become, the vehicles should not take any slipping that vehicle, because if it is having finishing more, it is going to slip it. So that the reason here the torque properties is going to be taken. So that in between the ramp to ramp they are going to put some grooves. They are going to put some lining, and that lining we will call as a groove. So every ramp they are going to put this groove. Even straight also we are going to put some grooves, because while moving your leg and ramp, there will be some friction going to be appeared in between the ramp and your floor and your leg. When you are moving from vehicle from one place to another area in the ramp, it is going to be take the grooveness, it is going to take the torque properties. So for that reason, this ramp will be decided based on the requirement from the floor. So whenever you are going to place this ramp, always here also the same. What is base level? If it is having ground floor, you have to keep the ground floor, because from ground floor to top floor, if you are going to place the ramp, so you have to place the base level as ground floor, and you have to put some base offset also, and again top level. Top level, if you are going to put some first floor, so it will be goes first floor, and top offset also will be there. If you are putting some value for the top, so the ramp from the top it is going to get some down. So by placing top offset and base offset, these two things will be indicating the slope. Indicates the slope angle. Because if you change any base offset, if you change any top offset of the ramp, it is going to be changed the slope angle also. So based on that, we can able to work out for the ramp. So here also every ramp there will be a railing also will become automatically. But if you require the rail, you just continue with the rail. If you are not required rail, you will leave with the rail. So like that, this ramp we are going to design in a project. So just you remember this state arc radius, and a ramp slab we will call as a rest slab, and the thickness of the slab will be 150 mm, and the ramp slope angle we will calculate with the help of this formula. Slope equal to length of the ramp divided by 1000, and the run width we are going to keep the ramp minimum 1000, maximum 5000. But the staircase 1000 is the fix. We will never put more than 1000. But here the ramp width we can able to change it, because depend upon the area, depend upon the size from one floor to another floor, the height, we will change the run width also for the ramp. So like that you just remember. And here this ramp also, the landing area will become, because we can land that area, again we can move it from other floor. So always your ramp slab is going to touch with the next slab. If it is having here ground floor, so if it is having here first floor, so it should be touch. It should be touch the floor. So like that we will design this ramp in a project. Okay.